Yeah. Okay, so let's get back going again. So the order that I had the slides in, I was going to do encryption next, but I'm just going to shift it a little bit to talk about lambdas, because I had that formally on the syllabus, and I didn't have encryption. What's that?
Are you recording again?
Yes. That better not be code for like I'm tuning out now. I just had one person like, "You're recording?" Like, yeah. That is not the goal of recording, right? Yeah. So anyhow, what we're going to talk about next is the anonymous interclass, and it's a segue as to what are lambdas, and to help you understand why we create lambdas, and how they can actually radically shorten the amount of code that you write. And hopefully you'll all agree less code is better, right? Makes life a little easier. So to illustrate kind of where we're coming from, what I'm going to get you to do is let's go back into why isn't my NetBeans coming up? Here we go. Okay. So what I'm going to do is we'll stay in the same package that we were in for the first half of the class. And this time what I'm going to do is I'm going to right click and I'm going to say new. And instead of saying empty fxml, I'm going to say Java FX main class. If you don't see that option available to you, go down to other, and under Java FX, hopefully you'll see it. Say next, and let's just say experiment with lambdas, lambda. I think I'm spelling that wrong for some reason, but maybe I'm just tired. All right. So when you do this, and zoom in a lot, wow, okay. What it does is it will create, it looks a lot like our typical launch method, okay? So it says here that our class extends the application class, right? So we're creating a customized type of application. And if we scroll down, the main menu looks the same, or the main method looks the same, calls launch. But what it does is actually a little bit different than what we're used to seeing. So what we're used to seeing when we create that empty fxml page is that in the start method, we load the fxml page, and then we'd have a controller class and whatnot. That is the preferred way of working, to actually do a model, a view, and a controller. But you can do everything natively in one class if you wanted to. It's just now you're compressing a lot of the different things together. So like your view and your controller capabilities are all merged, and sometimes it makes it a little harder to work with. But when you do this, if I say run file, what you get automatically is this little window that says hello world, okay? And if we look at this, at the code, it says, it creates a button object. On the button, it says set the text to say hello world. And when you click on hello world down in the console here, you see it says hello world, hello world. And then in here, it says button, set on action, and then it says new event handler, action event, and it has an override. And if you're not used to reading this, it's a little confusing. And what we're doing here is we're calling a method set on action, and we're actually passing in an instance of a class. But we can't really see how that's working. So I'm going to take it one step back so we can see what's actually happening here. So we're going to create our own custom event handler is what we're going to do. So let's go into our package here, and let's say new, and we'll say new class. And let's call this the say hello button handler. So we've learned about, when we talked about inheritance, right? We talked about class hierarchies, and we talked about interfaces before. So the idea here is that we're going to implement an interface, okay? The event handler interface. So a lot of the GUIs have event handlers and action listeners that are built into them. And so what we're going to say here is implements event handler. And when you do the import for this, make sure you get the JavaFX event handler. Okay. So remember, an interface, and I'll show you in the slide here. This is the event handler interface, what I've got on the slide. So remember, an interface it just defines abstract methods. There's no actual instance variables, and you can't implement any methods. Everything in here is abstract. Why do we create an interface? What's the purpose of an interface? Yeah, perfect. So for those that are listening online, what he said is we're creating a blueprint for all the classes that implement it, that they'll have to have this method. So in this case, if we create an action listener, we have to have a method called action performed. So we have to have that method, and it takes in an action event as an input. Okay, that's what the interface does. So it gives a generic way of handling all things, because button events, slider events, text field events, all these things are really triggering an action event. So if we were to create these all as separate classes, so here we say implements the event handler, and then it says we have to implement all abstract methods. If I click on it, we have to have the this method called handle. Interesting. Oh, event listener. Ha. Okay, so I showed you a different interface, but the idea is the same. We have to have this method called handle. And so in here, we put in whatever we want to have happen when our handle method is called. So what they had was system.out.println, and they said, hello world. We're going to say from inside our custom button handler. Okay. So when this special handler is called, right? When we call the handle method, we just want to print to the screen. Now we could do all kinds of things. We could trigger a database query. We could, connect to some external data source. There's all kinds of things we could do when they push the button, or we could change scenes or what have you. But the idea is that we have to have a method called handle. So right now with this class that we have here, are there any questions about it? It looks like one of our regular classes. It implements the event handler interface, which says we have to have this one method. So there's nothing too crazy in here, right? Just going to print to the screen if we call this method. So let's look at how we integrate this back in. So you see here, I'm going to take this little bit of code. I'm going to highlight it all and go hold down Control-Shift-C to comment it out. Okay, so that's what they did for us. And let's go up here and we'll say using our custom event handler class. We can say, we'll create an instance variable, right? So say hello button handler is our data type, and we'll just call it the button handler. Equals new, say hello. Okay, so I create an instance of my class, and then I can pass that in. So I can say button set on action. I can put in my button handler. Okay. So for everything we've done so far in the course, this is probably a lot easier to read, isn't it? Right? We have a class that we've defined. We create an instance of our class, and then we pass that in as an argument. Right? So the button set on action, when there's an action on the button, we call our instance of the say hello button handler class, and then it will automatically call this method. So let's try it. So if we go run file now, our GUI comes up. It's going to look the same. When I say hello world, it's calling our custom button handler instead of that one that was made by the IDE. Congratulations. Yeah. We need more of those. We need more of those. I think I did give you guys the goal of coming up with more congratulations types of waves. So yeah, so we got to do that. But that's what's happening. Okay, is it really we're creating a class, creating an instance of the class, and then we're calling this one method. Okay, and it works because it's looking for that method name. Now, this particular GUI has one button. So this isn't a big deal. But if you look at most GUIs, like pull up your lab from last week. What did I have you do in the lab last week?
Just one button.
Did I just have one button there too? Oh, darn. All right. What's that?
On different stages.
But different scenes. Okay.
On assignment 1, we have 2.
Yeah. Yeah, assignment 1, but every text field has different things too, right? So I'll show you a little bit of a something to, yes, it's a little bit more interesting. So let's say we were creating something like this, where I have a slider that will update every time they move, and a drop-down combo box that every time I select something should trigger, right? So if I select, I don't know, manufacturer Buick, maybe now there's only a subset of colors available to me or something, right? Something like this. And then each of these buttons is going to have its own, event. So if I look on a scene like this, I might have 1, 2, 3, 4, 5, 6. Whoops. 1, 2, 3, 4, 5, 6, maybe 7 different custom handler events. So picture how this is going to start to look in my project. So one scene has maybe 6 or 7 of these, what do we call it? Custom handlers. So that's 6 or 7 files. Now start picturing the naming convention on these things, right? It's the button handler. Okay, so it's the, I don't know, new car, save file button handler. It's the new car, pick new image button handler. It starts to create this like just a giant amount of files. And when we look in these files, there's almost no code, right? So a long time ago, people looked at this and said, this works, but this is actually pretty heavy, right? This is a lot of work. There's a lot of files. There's a lot of places where things could go wrong. It'd be very easy to get the wrong event handler. It'd be really easy if you're playing with different files, unless you have like a rock solid naming convention. So what they came up with was this idea of something called an anonymous inner class. So the idea of an anonymous inner class is it's a class that's defined. So here we're defining a new class, right? But we're not going to give it a name. It's anonymous. And the word inner means we're going to define it within an existing class. And that what that allows us to do is we can have the same behavior without having to create all these extra files. That's why we do it. So if you look at what they did by default here, so I'm just going to hover over those, Control-Shift-C to comment them out. And then I'm going to hover over these lines of code here, Control-Shift-C to comment them back in. So what you see here is on line 26, I say button set on action. Okay, so that's the same as the method we're calling on line 28. Okay, see how those are the same? What's passed in here is an instance of a button handler. Okay, it's an instance of the class. And if you look, we say new say hello button handler. Here, so if I look at this side, here I'm going to say it's a new event handler, which is what our button handler was, right? If we go to it, it implements the event handler. So it too is a type of event handler. So here we say it's a new event handler, but we never actually gave this class a name. That's the anonymous part. And because it implements the event handler class, it had to override the method called handle. Just like in our regular class here, we had to have this at override, and we had to handle that method. Yeah? We had to create that method handle. So that is what's happening here. We create a new class, and because it's a type of event handler, we override the handle method. So these are actually doing the exact same thing. Although this one's a little, I find, like for me, I find this one a little harder to read, yeah, than this. This is a much simpler way to look at it. But this puts everything in one file. And since I'm really only creating one method, it ensures that that method's associated with the right object. Right? So it actually does make things a little cleaner. Does that make sense so far? Yeah, I'm looking for.
Special code to make these interfaces like this, which can be anonymous.
Is there special code to make
It anonymous, like can handle anonymous.
Yeah, so you can create an anonymous class for a lot of things as long as the interfaces are set up. So like in this case, I talked about the event handler interface. And in this case, I had an event listener, right? So a handler is like an actions performed. A listener is waiting for something to change. So there are quite a few of these pre-built, the interfaces. And we're going to look at that next.
So
yeah?
you have a method, the handle one,
Yes.
that only happens when something is done to this button.
When there's an event on the button, yes.
Okay, so you need to have one button for each action that you want it to have.
Yeah, so I'll just repeat your question because I'm recording it. So the question was, do you need one action for each button?
Mm-hmm.
And the answer is yes. Like if I didn't have this set up,
Mm-hmm.
I'll comment it out for a second. If I were to run this file now, the window would still open, the button's still there, but because there's no set on action method, right? to happen, you have to update this. So case in point here, let's comment this out. I'll just take your idea here. So if we added another button. So oops, say button number 2 equals new button. See if I can spell this correct. Yeah?
Yeah.
All right. And I'll say, just do, you can see how it's so much easier in Scene Builder to just drag and drop these things, right? And what we're doing, you can do when you're using Scene Builder as well. I'll say VBox equals VBox. So we'll create 2 buttons and we're going to add them to the VBox. So we'll say VBox add items. No, yeah, I don't work this way so often. Get it. Pretty sure with VBox we have to first get everything that's there. Doesn't. All right, 1 second here. I'm used to working from this style. I always do everything in Scene Builder. That's okay. Let's do. Do a quick look here. Get children. See, they did it just slightly differently. So VBox, get children. We're going to add button, and then we'll add the second button. Okay, so what I'll do, we can kind of do it 2 different ways. Button number 2, we'll set up to our custom button handler class. And button number 1 will have this event handler. Say hello, say here, button 1. And our custom class here. So each one has their own event handler, which is where your question was coming from. And if we go back here, if we run this, oops. Did I? What's that? I didn't set the text no, but this does the same thing. And if it, even if it didn't, I should still see the physical button. I'm pretty sure. Why didn't I see it? Why aren't I seeing it? Ah, yes. Need to also add it to this. See, it's much easier to do the using the model of the view in the controller. You don't have to get into a lot of this. Get children, add this, do that. It just kind of handles it for you. All right. Run the file. Oh, I didn't do my VBox. Hang on, still not going to work. I need to also, I think I can do this. Root children, add VBox. I think I can get away with this. Let's see. Okay, it's ugly, but it's got 2 buttons. So when I say hello world from this one, we're getting button handler number 1. And with Enrique's special button, it gives us button handler number 2.
The biggest advantage is that you can handle multiple actions in just one class, just one file.
Correct. Yes. You can do it all in one file. The challenge with it, I find, is it's still fairly verbose, meaning there's still a lot of code here for really, we just want to print out something to the screen. And if you're not used to recognizing that this is an anonymous inner class, it can be a little confusing to read this, right? And so my code is bigger, maybe a little confusing. With Java 8, they came out with something called a functional interface. And the functional interface are a bunch of interfaces that are defined that have just one method in them. And because they only have one method in them, we can actually use something called lambdas. Did you guys use lambdas with C# or other? Yeah? Okay, so this is like, old school. It's really interesting to see the facial expressions. We're like, some people are like, yeah. And other people are like, I have no idea what you're talking about. You didn't use lambdas yet? No. Okay. So this is a good segue then. You'll be able to use it in both courses. There's people smiling at the back of their mouth. They're like, okay. So, but this is sort of how they evolved, is that, you know, originally we had to have separate classes. And this was a lot of code and a lot of files. So then they came up with the anonymous inner class, which looks like this. So highly effective, but still not as easy to read. And then with Java 8 and onwards, they've come up with this idea of a functional interface. And functional interfaces have just one method in them. So remember when we looked at our, go back a couple of scenes here. There. When we looked at this event handler, that interface has just one method. So with Java 8, they've created some of these functional interfaces, and we'll build some of them together here today. Time's going fine, so it should be good. So one of the functional interfaces is called predicate. And it takes in one argument, and it returns true or false. So let's start building these. I'll kind of introduce them, and then we'll build them, and introduce some and build some. And then we'll see how can we actually use these with our GUI to make our code radically shorter and I think a lot easier to read. But the key is to understand that these functional interfaces just have one method. And once you sort of get that, you're like, oh, that's it. Sounds all good, looks a little bit different, but it actually makes our code so much easier to read and write. So let's, let me just pull up on my prep here. Okay, so there we go. So let's add another new Java class. Okay, so right click on the package, new Java class, and let's just call this Lambda experiments. We're going to come back to the file we were working on. Once we figure out how these Lambda things work, we're going to see how we can shorten that. When we're done, what we'll do is all of this, we'll shorten to one line of code. So then you'll be like, ooh, I like it. It's so nice. Okay, so put in a main class, public static void main. And then, like my PowerPoint slide says, predicate, it takes in, this is a functional interface that they've already defined for us. It takes in one argument, and it's going to return a state of either true or false. So we'll say functional interface predicate. And if you're interested in this, there is on lynda.com. So you all have access to lynda.com. A lot of what I'm showing you today is referencing back to their instructions, their video series. So let's put a little title here: system.out.print. To catch our attention, example of a predicate interface. The examples I'm going to show you initially are really quite trivial. It's more so you get used to the syntax of how this stuff works. And then we'll start doing stuff with the GUIs to see how this can make our life a little easier. So how many methods are in a functional interface? One. Yeah. All right. At least one person was listening. Good. So to define this, it looks like any other type of thing that we define. So I'm going to say, so my data type is predicate. Okay. I'm going to tell it that I'm going to pass in a string. And let's call it PW checker. Right? Password checker, make sure it's at least 8 characters kind of thing. Equals. And here's where it's really interesting. With these lambdas, first you write the arguments. So I haven't named the class. Okay. Here I've named the interface is called predicate, but I don't have to say equals a new whatever predicate. And I don't have to actually name the method. Because how many methods do we have? One. And I got that answer in stereo. So that's good. This side of the room's a little bit quieter, right? You guys need to step it up, but we have one method, right? So we don't even actually have to name the method here. I just put in my little brackets. This is where my argument goes. So in here, let's just call it the string argument. Okay. So I haven't identified really the class, and I haven't named the method, but here's my arguments. And then I do dash and a greater than sign, and they have to be right typed together. Okay, no spaces. And then I just put whatever I want to do on the right-hand side of this. So in this case, I'm going to say, actually, rather than call it string argument, let's call it the password. I'm going to put the word argument in here, not to have an argument, but to actually just sort of really emphasize that this is the argument of our method. And what we're going to do is we say password argument dot. Sorry, I have to import here for our predicate. If you don't have Java 8, well, you must because you're doing JavaFX, but you need at least Java 8 for this to come up. But now I can say length. See how it knows that it's a string? I can check if it's is it greater than or equal to 8. So what this does is it basically creates, anytime I refer to PW checker, I can pass in a string, and if the string has at least 8 characters, it's going to return true. If it has less than 8 characters, it's going to return false. So imagine you could also do this with like dot matches and put in, you know, something that's going to check for uppercase, lowercase, and a certain number of characters and symbols and all kinds of things. So here we can say system.out the password Bumblebee is too short. And then we'll just have a Boolean for true or false, a new line. And then I can say PW checker test pass in bumblebee. So the predicate interface has one method, and it's called test. So when we set up our Lambda here, we didn't have to say that this is the test method. It already knows that. Should change it. Is big enough. And then we could do something that's maybe a little smaller. So system. What's great is with lambdas, we can kind of not get stuck with the anonymous in your class. We'll get to jump right past it. But I show it to you because it's part of the evolution of it. So here is where we've created our lambda expression. That this nice little arrow is telling us with this input, I want to evaluate this. Okay. Now, you might look at it and go, what's the value in that? That's not really saving me any coding space. The second one, the password, yeah, is it big enough? It returns false, meaning it's not big enough. Yeah. So with these, you can put over here, you can put a whole bunch of code. Like you can actually put like these curly braces. Is that crying? Oh yeah. Well, if I had an if statement and stuff, I could kind of make this a little bit better. I'll show you another one where we can do that a little bit easier. But the idea is you're calling a method and you're creating your own custom method. So this is the equivalent of, remember in our say hello button handler? This would be the same as creating a public class password checker, implements the predicate interface. And then there would be one method called test, and it would return this. That would be inside the method test. Let me show it to you that way, just so you can sort of see what it is. So let's do that. So we'll create a new Java class, and we'll call this the predicate, or let's call it the PW tester class. So if I said this implements predicate, give me my imports. Okay, so if I had my own password testing class, and again, this is a very simple test, but we could put a lot of more complex things in here. The little light bulb here says we need to implement the abstract methods. So in order to implement the predicate interface, I have to have a method called test. That's all that that's saying. So if I wanted to do this equivalent, And here I would say string. Oh, it's not gonna let me do that. Okay. So here would be return and pass this as a string. Key dot. Let me do this. I want it to let me pass it as a string. I can do that. All right. So if we were to do it the way we've kind of learned how to do things so far, without lambdas or anonymous inner classes, this is how we would maybe go about doing this. Is we'd create a password tester class, and we include a method in here called test that would accept an object. We force it to be a string and confirm if the length of that is greater than or equal to 8. So this is equivalent to right? This is the other way of doing it. You could create a class, and you could create a method called test that will return the same thing. So you see how this is less code? Let's do a couple more, and then we'll go back to our GUI example. And if you've got questions, or if this looks like complete gibberish to you, please stop me. Because I'm like a mad scientist, right? I'm going to keep talking. Okay. All right, so that's the predicate. So another type of functional interface is called the consumer. This one takes in an argument, but does not return anything. You know, I put in here it's consumed. So let's take a look at a classic example here. So copy my fancy line from above. And we'll say example of a consumer interface. In this case, whatever string I get, I'm going to convert it to uppercase. So again, this could be a whole lot of code. It doesn't have to be a single line of code, but it has to be one method. We're going to call one method here. These examples are purposefully trivial so we can just work through them, but so here I can say with the consumer interface, maybe I'll add in one more comment here. Consumer interface has one method called accept. I say display.accept, and I can pass in a string. So I could say, everyone loves Java with an exclamation mark. So what's happening here is we've created our instance of a class, so to speak. Well, we've created a class called display, and it's going to have a method called accept. So if I run this, you can see it converted everyone loves Java to uppercase. And you can have it consume a lot of other things and do a lot of other things. It doesn't necessarily have to display to the console. The idea here is that it's not returning anything. The return type is going to be void. So in the predicate interface, the return type was Boolean. In the consumer interface, the return type is void. But these are just interfaces with one method in them. And that's how come we're allowed to use this little lambda notation. Okay? This is like the same thing as kind of creating that anonymous inner class. And the nice thing is we can reuse this wherever we've defined it, right? So if it's in a method, we can reuse it multiple times throughout. Okay. Let's look at another one here. Function interface. This one takes in an argument and returns a result. Type 2A. So this one uses the method called apply. Define our function. The input will be an integer, and the return type will be a string. So this interface, you define the input type and the return type. My argument would be the integer to convert. And I use my lambda notation. And all I'm going to do is I'm going to convert this integer into a string. Right? So that means I can use the integer.toString method and pass in int to convert. Do my imports there. So in this case, I take in an integer. I'm going to return it as a string. And you could think of again, this is it's really no simpler than using integer.toString, but perhaps you'd want to set up some custom handling of how you handle an exception or something in here. Like instead of it throwing an exception, maybe you want to create a modal pop-up on your interface and do something. So let's do a little system.out.print here, printf. So here, what I'm going to do is I'm going to doing two lines. The first line just says 5 plus 5 is going to equal 10. And then I'm going to do the same thing. I'm going to pass in 5 and 5. I'm going to pass them in as string objects. And what we'll see is, 5 plus 5 as strings returns 55. So I'm going to say converter, that's the name of our little class here. And I'll say apply. And I'm going to pass in the number 5 plus converter apply. It'll convert the number 5 into the string 5. You can see how when they're numbers, they add up to 10. And when they're strings, they add up to 55. Because plus with strings is concatenate, right? It's concatenating together two strings. So you're starting to see the pattern here. Our arguments are the lambda notation. And then what do we want the method to do? But we don't have to specify method names here at all, right? So we don't have much time left in the class today, and I want to make sure that there's time for questions if you got any. So let's go back to our GUI. Okay, so you're seeing the pattern here now, right? So we have a functional interface that can accept arguments, and then we use this lambda notation to do whatever we want it to do. So if we go back to our code here. Okay, so this was our code for bringing up our GUI. So right now, if I run file, it looks like this. And when we say hello world, we can see that we're triggering this anonymous inner class and the button. So I'm going to comment this out. So Control-Shift-C. Now let's do the same thing with a lambda. I'm going to say button, set on action. So this part's all the same, right? This is where we can put in the lambda event. So what's my argument passed in is an event, yeah? So what I'm going to do in here is I'm going to say event, and I'm going to use my lambda notation. And I can do system.out.println 1. And if I come back here now and say hello world, it's calling my method. So you can see how these lambdas radically shorten the amount of code we have. And actually, I personally feel it makes it a lot easier to read. And allows us to put all of our methods in one spot and really associate it with our objects quite easily. So let me just throw that onto GitHub. Git. Okay, and that's a good spot to leave it for this week. Okay, In the slide deck online, I think I mentioned a lab in there, but that lab was related to encryption and hashing, which we haven't got to yet. So you don't need to do the lab for that. If you look through the slides, you'll see it there, but you don't have to do it. There's nowhere to submit it. So you can do it. It's not a bad exercise, but we'll get back to that in another class. What I would say is, for what we just looked at with these lambdas, they're very, very powerful. Again, check out on lynda.com. Just type in like Java lambdas, and you'll see, I think her name's Peggy. There's a whole lesson on it. So parts of it are gonna be similar to mine. And then, she keeps going. So it's a good way to like enhance your learning of this area. Okay. All right. So we'll see you all next week. Have a great Easter for those that are celebrating Easter.